Hi everyone, coming back to MRI basics. Today we'll be learning about what is longitudinal magnetization. Before that, first we have to know, so this is the Z axis, Y axis, and we have X axis. One thing you have to remember is the Z axis runs in the direction of the magnetic field. Remember, the Z axis runs in the direction of the magnetic field. Then we have a proton which spins around its own axis. This proton, we represent it as a vector. Okay, normally what happens, a vector, it represents certain force. So the force that is represented by the vector is magnetic force. So this one you remember. Then coming back to basics, so as we know, the protons, they'll be aligned randomly. So when you keep in an strong external magnetic field, they align parallel or anti-parallel to the external magnetic field. So they don't remain like that. They have a movement that is called as precession. This one you know. So they have a precession frequency. So now what happens? So this is, so as I told you, in an external magnetic field, some align parallel and some align anti-parallel. So they have certain movements that is called as precession. So you have to remember that this proton and this proton are opposite to each other. So the magnetic force of this proton and this proton, this vector, they cancel each other. So at the end we have certain protons that are pointing upwards. Okay. So we remind the protons which are pointing upwards. So here also some of the protons which are in the XY plane. So protons, here we remember it as vectors. These vectors which are in the XY plane, they cancel each other. They cancel each other. Then the vectors which are in the Z plane, Z axis, they don't cancel each other. Why they don't cancel each other? Because they point in the same direction. So they add up. So they add up and form a sum vector. So they add up, form a sum vector called magnetic vector. Okay. So the vectors along the X and Y plane, they cancel each other. The vector in the Z axis, the vectors along the Z axis, they point in the same direction. So they add up and form a sum vector. That is the magnetic vector. This is the magnetic vector. So you can get a signal from this magnetic vector. And it is the new magnetic vector, it can be used to get a signal. Okay, remember this. And this magnetization is longitudinal to the, we know that this Z axis runs in the direction of the external magnetic field. So this magnetization is longitudinal to the external magnetic field. That's why it's called as longitudinal magnetization. So as I told you, this magnetic vector, we get a signal. So we have to measure this, but this one cannot be measured because as it is parallel to the external magnetic field. To measure this magnetization, this one should turn to the transverse. So we need the magnetization which is not longitudinal but transverse to the external magnetic field. That's how we measure it. Thank you.